guys, what's up? So today we're going to be going over the FRQ problem from 2014, question number 5. And this is going to be regarding the topic of areas between the curve, volumes of revolutions, and also arc length. So we're going to start out with the function over here represented by y equals x times e to the x squared. And this function right here is going to be y equals negative 2x. So the first question states to find the area of R, and R is represented by the green shaded area inside these two curves. So we know that integrals can be used to find areas under the curve, so we're going to use our knowledge of integrals. So we're going to do the integral from 0 to 1, and we're going to do the top function minus the bottom function, because if we just do the top function, we're not going to be able to cancel out this part. But if we also subtract the bottom function, we will be able to subtract this part right here. So we're going to do integral from 0 to 1 of x e to the x squared minus negative 2x with respect to x, of course, because we're doing it on the x coordinate. So we're going to have to solve this problem, and the way we can take the integral of x e to the x squared is we can just do a u sub. So u equals x squared, and then u prime equals 2x. So then we'll get that 1 over 2x, the integral of x e to the x squared. The x's will cancel out. I'm sorry, this should be e to the u. And we know that this will cancel out with this x. So now we just have the integral of e to the u, and that's just going to be e to the u, just as the derivative of e to the u would be e to the u. So we're just going to get half e to the u, but we're just going to replace u with x squared, which is what we set it as before. So now we're just going to have to take the integral of the second part, which is positive 2x, because these negatives cancel. So the integral of positive 2x will just be x squared. And this is going to be from 0 to 1. So we're just going to plug in 1 for both, and then subtract it once we plug in 0 from both. So when you plug in 1, you're going to get e over 2 plus 1. And then you're going to subtract, when you plug in 0, you'll get a half plus 0. So it's just going to equal e plus 1 over 2 once you simplify it. So that's the area of R. Alright, cool. So the second problem wants you to write but not evaluate an integral that gives you the volume of R when it is rotated about the line y equals negative 2, as I've just drawn. So for volumes, we're still going to use integrals, but this time we're going to multiply the integral by pi. So let's do it over here. So because it's a revolution, you know? So you multiply it by pi, and then we're going to have the same boundaries from 0 to 1. And then this time we're going to do outer radius minus inner radius squared. So outer radius, the first one is going to be x e to the x squared minus the inner radius, which is going to be the line, negative 2. So once you subtract that, subtracting the negative will just make it positive. And this is all squared. And then you subtract that from the second line, which is negative 2x minus negative 2, which is plus 2, all squared. This will be done with respect to x. And again, we're going to be doing the subtracting because we don't want this region right here. This region right here, we don't want to be included, so that's why we do the subtraction. So this right here will represent the volume of R as it is rotated about y equals negative 2. Okay. So now we move on to the final problem, which states to find the perimeter of R. So this time we can notice that there are some straight lines on this graph, which we can just find the length pretty easily. So we know that like this triangle that forms here, we know that this distance is 1 because this x value is 1. So this is going to be x equals 1. So since this is 1, this, once you plug in 1 to this for negative 2, you're just going to get 2 for this distance. And then this will just be root 5 by Pythagorean theorem. So now we have 2 of the lengths. So if you also plug in 1 for this function, you'll get 1 times e to the 1, which is just e. So this is just going to be e. So I'm just going to erase this to avoid confusion. So this line, this right here, will be 2. This one right here is root 5. And then we have e. So the last one we need to find is the curve. And you can't use the same method that we used to find the other lines for the curve because it's not straight. You can't find it that way. So we're going to use the arc length formula, which will be represented by the integral from 0 to 1 of so 0 to 1 is just the boundary. So if we were trying to generalize it, it'd just be from like x1 to x2. So these are any values, like these are boundaries basically. So you're going to do the square root of 1 plus the derivative of your function squared. So dy over dx squared. And this is with respect to x. So this is the arc length formula. So now what we just have to do is derive this function and plug it in. So y equals x e to the x squared. And we're just going to skip over the deriving part because it's just we all know how to take the derivative. We just use product rule. Yeah, so once you take the derivative, you're going to get e to the x squared times 1 plus 2x squared. So just going to plug that into there. So the final answer is just going to be root 5 plus 2 plus e, because these are these distances that we just calculated, plus the integral from 0 to 1 of root 1 plus what we just calculated here, and that's all going to be squared with respect to x. So that's going to give us the perimeter of R. So that concludes the video, and if you guys still have some questions or you just want to get some more practice with this topic, you can check out FRQ problem number 3 from 2011. It covers basically the same topics that we covered here. And also, if you want some more practice and if you want to watch some other videos, I can leave a link in the description for Khan Academy. They have some good videos that can explain this as well, and they have some practice problems as well. So that's going to be in the description. So thank you for watching, and if you found any of this helpful, please like, comment, subscribe, share, and yeah, thank you.